Testing. Testing. Nothing good up. Let's go. Testing. Nothing good up. Let's go. Testing. Awesome. Hi guys, long time no see. I know. So I'm finally back. Back after a long time. So, newsflash, I was studying all this while and finally did get a job. If you were there for my last stream, I said I was studying to get a job and I was streaming on leetcode till I got a job, but then I quit leetcode because I found it to be more distracting than productive at the time. And I don't think I was going to be any more helpful streaming than studying by myself. So that's when I decided to quit streaming. But so this news is sort of old. It's been about half a month since I got the job offer for my new job, and yeah, I'm going to be working at Microsoft. So as a software developer, but we're not going to give up on solving problems. I did try and solve problems after the interview. Still, I was actually sort of the last job that I applied for. I ended up getting it. Lucky me. So today we'll be doing hard problems only. Turns out most people have done like 80, 40, 80, 60, 40 problems. So we're missing the hard section. Let's practice that today. I'll just be right back. Alright, so I think two hard problems for a day is fine. Um, just start order five. Okay, this is a downvoted problem. Next, if new here, we're not doing downvoted problems. Are these all? Oh, okay. Recover binary search tree. That's nice. Two elements of the binary search tree are swapped. Recover the tree without changing its structure. I think of a binary search tree. Okay. I think I've done this question. Are there any follow-ups? Solution using ON space is pretty straightforward. Could you devise a constant space solution? Okay, so I think there might be a another medium question, same question, medium level, which expects you to make an ON space solution, which is basically put the iterate through your tree, put it in an array, see if it's sorted or not, and see what elements are not sorted. If they're not sorted, like whatever two elements are swapped, just swap them. If they're not in position, and you'll have your answer. Okay, but they're saying, could you devise a constant space solution? So, I think one option which I see is when you check if a tree is a valid BST, a binary tree is valid BST when you check every node uh, and you pass two things, min and max for each node. So in case two elements are swapped, for some nodes that condition is going to fail, right? For example, if you see here, it's 1, 3, 2. So for this, everything on the left has to be. Um, is there a number of elements constraint? Okay, no. On the left has to be number smaller than the current number. So for 1 it fails, right? For 3 also it fails in a way that on the right there should be a smaller number. So the structure is correct, what they're saying is. So only the values would be swapped. Nothing's gonna go left or right. So 3, 1, 4. So 3, 1 and 4 seem fine. But when you compare 4 and 2, you see that 2 is less than 4, but 2 is more than the minimum number, which is 3. So in that case, how do you know which ones to swap? So we know 2 is, so either the parent you just found that violates, that does not match with your current node is the screw up, or the node that you just found is the screw up. Or if they are in different trees, now if a child does not match with the parents, then the child is at fault. But if the children of a node are greater than the node, on the left side are smaller than the node on the right side, then the parent might also be at fault. So, oh, so you can't change the structure, right? So if on the left you have a number greater than the parent, you can switch if the parent is smaller, if the parent is on the left side and is smaller than the root. If the parent is on the right side of a tree, switching it would not matter. Okay, okay. Let's screw that approach. Let's just say that if a node does not match the criteria of one sec. So if a node does not match the properties, um, ah, of does not satisfy. Okay, let me write it down. I'm just talking in the air. So a tree is a BST if it um if 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 a node is if a node is left child of root node of its parent and is smaller than the parent but larger greater than the minimum value in that subtree. Second, if a node is right child of its parent and is greater than the parent, but it is smaller than the maximum value in that subtree. Wait, is that true? The is the right child max. Okay, so let me give you examples of this. So now 3, any child of 3 cannot be greater than 4. So 3 had a right child, it could be 3.5, but it could not be 5 because this everything below 4 on the left side has to be smaller than 4, and everything on the right of 3 has to be greater than 3. It has to be somewhere between this. So right child is greater than the parent if you're talking strict BST. Um, let's just say strictly parent, but smaller than the maximum value in that subtree. So it has to be smaller than 4. Similarly for the left side. So we can say a node is not at the correct position in a binary search tree if starting at that node we cannot say that is the node this node is a BST. This starting at that node, this is the root of a BST. And also, if inside that BST we find any node that does not satisfy these two conditions. So for example, for this tree, 1, 3, 2, 1 fails directly because, I mean, okay, we're not checking parents, right? Yeah. Yes, 1 fails because um, 1 is not a BST. I mean, this tree with 1 as node is not a BST. And 3 fails because um, 3 as the root node of a tree is not a BST. So what we can do is comment this. Is you can keep, let's just keep an array. Oh, it's almost like I've forgotten how to write code. Okay, so in this list we'll push our 2 elements that we find. Um, let's just swap the values at the end. So is BST root int? There's no values given, so let's just assume int min and int max as our limits. So is BST, we have a node and a min and a maximum value. Now, if it's no, if it's null, then just return true. It's okay. If node value is it is a BST if node value is greater than min and node value is less than max. If बोलो bye bye. We can text if you want. Okay. If node left is BST and is BST the right one is also BST. So if this constraint passes and this constraint passes, then you do nothing. But if either of them fails, if all these constraints are true, else this node is list dot push back node. And I guess return true. We can return true here. Why? Hmm. So we would still be checking for each node, right? Even if it's returning false, it's going to check for children. Yeah. Okay. I think this actually this should be enough. So if a node is a valid node of a BST, a valid root node of a BST, and valid node of a current tree as well. Oh, sorry. Is BST left? Now the limits would change if for the left children your current node would become the maximum, so node value would become the maximum and the minimum would remain the same, and for the right one the current node would become the minimum and the max would remain the same. So if each node is valid node of a BST as well as a possible root node of a BST, then we can say that that node is in the right place. Otherwise, that node is not in the right place. In the end, we should probably have two items in our list. If list dot size equals 2, int temp equals list 0 val, list 0 val equals, so there'll probably be, so there'll be, will there be references? Should be references equal to list 1 val, list 1 val equals temp. Sorry. Thought I read something weird somewhere. Okay. Well, looks good. Let's try another test case. Then this one test case that I would like to run is where the swapping is between two different nodes, like into different subtrees basically. It's possible. Oh, failed right here. Output is the same. Whilst expected is this. Okay, yeah. So let's see what failed. What had to be swapped? Oh, root nodes. Yeah, root nodes are something I think that I've not thought I had not covered. Hmm. Oh, so basically, I think where I'm failing is this would say false, and this would say this should say true, right? This is in the right place. This should return false in the end for each node. Um, if I think so, these conditions need to be separate. So if a node is satisfy the condition of a tree, then you need to return if the children are satisfying the conditions or not. Else, else you push it in the list, then check for their children separately. It's going to be a separate task, and then just return false because they did fail. Ain't that so? Oh, so if it failed, maybe this max and min is actually not the correct value. So maybe you have to treat it like a new tree itself. Let's see what the size of our list is. It's not updating anything, of course. 1. Hmm. 2 is the value that's getting added. So how is 2 false? Uh, how is 2 even false, dude? That's crazy. Um, I don't even know if that's a function. Okay, it is. So if current, so no, so that's wrong, obviously. If current node satisfies the condition of its current position and so this has to be together, right? And it is a valid BST, then then return true. If not, if not, had I had I written this itself? Oh yeah. Oops. Oh no, I had not written this actually. So you need a whole lot more conditions to be true. List dot size now 3. Okay, that's crazy. And what exactly are all the elements? May I ask, Mr. leetcode judge? So the elements are 2, 4, and 3. So how is okay? I don't know how even 2 is getting added. So ah 2. So 4 is 4 valid as a node? Yes. But then 4 checks 2. Checks 2 with the what's 4 checked with? Okay, so 3. How is 3 checked? 3 is valid. It says 3. No. So while checking 3, it checks 1, which is valid. Then it checks 4. which is on the right side of 3. Yeah, it's valid. And then it checks 2, which is valid. We make a set and check if it exists in the set. um, so we find that 2 does not satisfy the condition, so 3 should be added, right? First, let me check 4. Is 4 greater than 3? Yes. I think I might have been writing this wrong, maybe. Int min. For 3 it's fine, and with the right node that value is the minimum and maximum is maximum. So for 3 and 4 it's right. So for your left node, then for 4 we check the left. So the minimum is 3, and then for 2 we return false. So 2 does not satisfy the condition, right? As well. Ah. Hmm. So actually, what we need to do is only if we are treating the current node as the, how does 2 not satisfy? Why does 4 not satisfy the condition? So each node that fails to be a child of any other node in the tree is should be added to the list. If any, so where did 4 fail? Because one of its children failed. Is that if a node does not satisfy the min or max value, then that node needs to be added to the list. If it does satisfy that, okay, let's so if, let's just copy this. If it's less than equal to min, or if it node value is greater than equal to max, then that node is a bad node, and we return false for that node. Else, we check for its, we check for the same thing for its children. Else, if if its children form a if its children form a valid if chil if okay, so if it is a valid node in a BST, now else if it's not a valid node in a BST, it needs to be pushed in the list. Just push it in the list. Okay, don't blame its parents for everything. If the current node is not a good child, I failed. If it's a good child and both if both of them are like Gucci, right? If everything is super, if they are Gucci as that's not true. I've been thinking so much about this. Else, if both children do not satisfy being legit parents. What this bracket if else oh, what the heck? Anyway, um else if the node didn't satisfy that, if the node did satisfy a node condition but didn't, then we checked for, I think I might have written the same thing, but I'm just writing it in a different way now. Unless this works. No, I think I've written the same thing. Now suppose 2 got pushed in when? So is 3 Gucci? Yeah, it's nothing there. Then checks for left, checks for right. Left has nothing. Right says, hey, is 4 good for his position? Yeah, let's go in. Is the left of 4 good for its position? And is the right of 4 good for its position? No. So is it 4's fault or is it the child's fault? I don't know. Hmm. Maybe if we check that if both the children are independently good trees, then it's this node's fault. Else, else it's not, right? Uh, okay, let's check. Fail for we can add like max, min as well. 1, 2, 3, 4, 5. So failed for let's ignore this. Hmm. So failed for so here we fail for 2 where max is 4 means 3, so 2 is pushed, that's fine. That's in our first recursion, I think. Then the second fail we get is for 4. The maximum is int max and minimum is 3. Why do we fail here? Is because 2 failed. But how can 2 fail for int min and int max? Oh, sorry. Oh. Huh? That doesn't make any sense. How is 4 failing here? Maximum is int max, min is int min. So it doesn't fail for the values, right? Then we check if if 2 is so is min max position, right? Yeah. So if uh let's see. Left is this and right is this. When it fails, left is this and right is this. Oh, this hasn't failed. Sorry. My bad. How did 3 end up here? If they're independently good, wait. If they're independently good as children, if the node satisfies, oh, I don't have to check the children to be. I just have to ignore the parent, actually. We check if this node is not Gucci. Then we push to the list. Right. As an independent tree. It's like, we're checking for node itself. So if the node doesn't lie in the the output? 1 fail for 243. What were we printing? Cout 2 fail for print 2 fail anywhere? Oh, okay. Let's see what went wrong. So if everything's fine, so check for 3. If 3 is fine, right of 3. We check for 4. Is 4 fine? Yes. Is no. Is false. We go here. Then check if 2 itself is a good independent thing. Maybe so heck if list dot size equals to return don't do anything out of that. Oh, set start cert. Uh, set. Okay. I don't even know how to say that. Auto x equal to set dot begin list dot begin auto y equal to x next list dot begin. Totally hacking this question right now. Temp equal to x dot value. This becomes add x y. I have no idea if this works. I don't even know how. Next fade before that is not a struct or union. P P poop. T what? Do we let's try dot. Member reference base type is not a structure union. Member reference base type. To call a member function. Da, 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 da. Hmm. did this, but it didn't seem to work at that time. Is not a struct or union. Let's try. Let's put a bracket and see what magic happens. Doo -doo -doo. Okay, okay. Alright. What is X then? What is the type of X? Iterating a set C++. Whew, okay. Star ID gives the value of. Oh, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, cool. Star X, star X. Let's replace that with Y. No idea if this is even gonna work. But technically, let's say that 2 and 4. I mean, oh, okay. Failing for 2 with 4 and 3. When am I calling is which node am I calling? I think I'm calling 3 again and again. If 3's already failed. Ah. If list dot find node not equal to list dot end, return true. Fail for 2, 4, 3. So okay, I think at this point we're just hacking. It's been, I think, over an hour since we came here. I think let's just see the solution. To pass DFS. Simple. Let's see. Helper. These are the two values. Helper on the left. If, what is this? It's kind of ugly. Let's see if there is a. That is also ugly. Okay. Hmm. Try and read this ugly one. Hmm. Oh, where are we? It's called hot. Most votes. Ah, that's what I was thinking to do. If first element has not been found, assign it to. What is previous element by default? Min value, okay. If first element found, assign the second element to the root. If first element is not null and previous is greater than root dot earlier. If first element is found, assign the second element to the root. If the value of if the value of oh, so you'll always be here. Previous element will be root, and then you traverse root dot right. Then when you're doing that, it'll say if the value of that is greater than the current node's value, say it was something like let's see. Need to find first and second elements that are not in the right order. How do we find these two elements? We compare each node which is with its next one, and we can find out that 6 is the first element to swap because 6 is greater than 3, and 2 is the second element because 2 is less than 5. Hmm. So you're just traversing. You are keeping the previous. So basically the root, the parent. So maybe that's not going to be 2 questions per day. It's going to be just this one. We have to figure out a simpler way to understand this. Really, what we are comparing in the current node and the previous node is the in order traversal. Yeah, so that's what I was trying to do. What I was not able to do is to check if I'm not checking the. I am checking that. Oh, so what you are saying, if two nodes are not in order, then the parent is the issue, right? For these, they are in order. So what I'm saying is if a child fails to identify itself as a child of a tree, if a node fails to identify itself as the child of any uh, any node as the root node, uh, because of the because of its value being not in place, then it's a problem. And if a node fails to identify itself as a root node due to due to not satisfying the conditions of BST. That is, left child is not BST, right child is not BST, or current node is valid, current node doesn't satisfy the conditions of BST. That node is fine. I think this is checked for 4. Four, 8. What is this? 132. So 132 fails for 3. Fails for 3. This node failed for 1 as well, man. Like this, the swap failed or something. No, okay. Obviously it didn't work. So 1, you were checking. Mm-hmm. I should have done false. 3, else इसके children are independently okay. And 1. Start with 1. क्या valid है? नहीं. False. वो जैसी false होता है यहाँ आते हैं. And then it starts checking for it again. If min equals int min and max equals int max, okay, ये लो हो गया. There is some hacking. I mean, I essentially did the same thing as others. Was maybe sort of. I mean, this checked the order. So I have 3. So this is 3. How's it 3? Okay, I can did that. Yeah. One fail for 2, 4, 3. One fail for 2, 4, 3. Noded value 2, 4, 2 does not. Okay, that's fine. 2 is pushed. Then checking for 4. Checking 4. Checking 4. If 2 fail for 4. How can you fail for 4? How do you fail for 4, dude? How did you fail for 4? Oh, frick you. Screw that. Why is that line still there? Just need to check if this solution works with that as well. Please, 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 please. Oh, God. Can't tell you how relieved I am. So I don't think I really did any hacks as such. I just got my code to work. I just had to check, what are the correct conditions, where and what. Alright, so we left with one case, which was take this and swap 1 and 4. And see if they're swapped in outside their places. Are they fixed or not? Output was 4 to 1. It was expected to be 2, 1, 4. 4 to 1. 2, 4, 1. So 2, 4, 1 says that 2 is in the wrong place and 4 is in the wrong place, and then 1 is in the wrong place. I did it even it did swap. Somehow list sizes was 2. 241 null null 3. 24. Oh, do we have a visualizer here? Yeah. 2413. So 2 failed, obviously, because it said 4 failed, and 4 failed because it did not satisfy the min condition. It wasn't smaller than the min. And 2 failed. Even check the right side. Just have the 4 and 2. Hmm. Hard problem, man. Hard freaking problem. Well, hmm. This, as soon as this is turned false, this went to this. And it didn't. That's fine. But did it not check the right one as well? Well, I guess. Put on these solutions. The weirdest solution which was. This was the. So I guess our logic wasn't correct. What my logic said was that if what my logic said was that if it doesn't satisfy as a value, then it's an issue. What it says is the same thing, same thing. Well, alright, let's try this tomorrow. Let's try this again tomorrow, guys. Good luck. Bye bye.